So this video is a practice exam 1 review, and we will go over questions that were on the PDF sheet as a supplemental video to the other practice exam questions. So let's look at question 1, which is evaluating limits. Specifically, we're evaluating them algebraically. Okay, so when we evaluate limits algebraically, the first thing you always want to try to do is to substitute in. So if you substitute in and you get an actual number that works, then that's your answer. However, if you get 0 over 0, that means you must factor both the numerator and denominator if you can. You're going to simplify, and then you're going to evaluate the limit one more time with the simplified version. If you get a number over 0, that means your answer is either going to be positive infinity, negative infinity, or DNE. Usually there's a direction involved in it, so usually it means that like it says x is approaching a number from the left side, and that'll give you positive infinity or negative infinity. If you have x approaches some number and the left and the right are not approaching the same, that's the only time you get DNE. The left side limit does not equal the right side limit. Now this is only if x is approaching a number. If you have x is approaching infinity, the rules we have is you look at the degrees of the leading term in the numerator and denominator. If the denominator is bigger than the numerator, then the limit is 0. If the numerator and the denominator have the same value in their exponents, then the limit is the ratio of their coefficients. And if the numerator is bigger than the denominator, then the limit is either positive infinity or negative infinity. Okay, so let's do that with these questions here. So looking at question number 1A, we're going to substitute 0 in. So we're going to get 0, 3 times 0 squared, plus 4, all over 0 squared, plus 6 times 0, plus 1. So the numerator will just be 4. 0, 0, plus 1 is 1, so the answer is 4. Okay, let's look at question B. If I substitute negative 2, right away if I put negative 2 here, I notice that this denominator is going to go to 0. So the denominator is 0, and if I think here, if I put negative 2, this will be 4 minus 6 plus 2, that's also 0. So you're going to get 0 over 0. So that means you must factor. So let me see what my values are again, because I really can't see it. So since you get 0 over 0, we're going to factor it. So factors of 2, when are added, give you 3, so that would be 2 and 1. They're both positive. They're both going to have the same sign, and they're both positive. Then notice that the denominator is already factored for you. Using the cancellation property, you can divide out the x plus 2's, so you're left with x plus 1 all over 2x. Now you're going to substitute that negative 2 into there. So negative 2 plus 1, 2 times negative 2, so it's negative 1 all over negative 4, so the answer is a positive 1/4. And lastly, this letter C is the infinity rules. So we look at the highest degrees, and the highest degree in the is in the numerator. So the answers are going to be positive infinity or negative infinity. So just take a look at that for a second. If you simplify this, this is x to the 8th. If I put an infinity to the 8th power, it's going to go to positive infinity. Okay. Now let's take a look at question number 2. Okay, so in this question, you're looking to evaluate the limits on sided limits, so left and right side limits. And in question D, it should be as x approaches 3, so we'll use it as 3 so that we can have the full idea of the question here. So notice that minus sign here, this means you're approaching from the left side. The plus sign means you're approaching from the right side, and since there's no sign here, what you're looking to see, well, does the left side limit equal the right side limit? If it does, then that's your answer. If it doesn't, then the limit does not exist. Okay, so let's take a look at this portion. Now, these are what we call piecewise functions. X is less than or equal to 3 is telling you the direction. That's to the left of 3. Set your left side. X is greater than 3. That's to the right of 3. So there you go. Those are your directions. So that's basically telling you what you're going to substitute in. And when it comes to getting graded for credit on your exam, what we're looking to see is that you substitute the 3 into the correct side. So in letter A, you're going to end up doing the limit as x approaches 3 of x minus 1 squared. So remember our rules of valuing limits algebraically, you substitute the number in. So it's going to be 3 minus 1 squared, that's 2 squared, so that's 4. That's your answer for part A. Now for part B. Part B says look at the right side. So we're going to do the limit as x approaches 3. On the right side, so that's going to be 6 minus 2 over 3 to the x. Notice I don't put an equal sign between the limit and the function itself. Don't, because that's part of the equation. The equal signs go before and after it. Now let's substitute in the 3. So 6 minus 2 over 3 times 3. That's going to be 6 minus 2, and that's 4. Okay, check that out. Now, does the left side limit equal the right side limit? Yes. So therefore, this is 4. Okay, now, continuity has 3 different rules. So continuity rule number 1, does the value exist at that point? Question 2, does the limit as x approaches that number exist of that function? And does the limit at that value, does the limit of the function equal the value at that function? I squeeze it in there. Okay, so let's do those pieces. The only thing we actually don't have an answer to yet is f of a, because notice that we did this part, that's part C. So we know that that's 4. And we can't answer part 3 till we get part A, part 1. So f of a means, okay, you want to evaluate that function at 3. So look up over here, notice, see the equal sign here? This is where the function is equal to 3. So you're going to substitute 3 into that part only, because it's the only part where it's equal to 3. It's not equal to 3 using this piece, just this piece. And deja vu, you did it already, right? So this is 4. So the value at 3 is 4. The limit as x approaches 3 is 4. And so therefore the limit exists. So the way we write our sign, the way we write it is we say yes. We say yes because the limit as x approaches 3 of f of x is equal to the value of the function at 3. So in question 3, you're asked to find the derivative. So you're going to use your derivative rules. So the first derivative rule you want to remember is your regular power rule. And your power rule is nx to the n minus 1. That's your basic rule. Please do not use a limit definition of the derivative. That's only if I ask you to find the derivative using the limit definition, not on any of these questions, so don't do that. If you have a product, you're going to use the product rule, which is u prime v plus uv prime. If you have a quotient, you use the quotient rule, u prime v minus uv prime all over v squared. And if you have a composed function, so like for chain rule, so your derivative is going to be the derivative of the outside function times the derivative of the inside function. Now let's talk about what each one's going to give you. So this first one is a product rule with a quotient rule inside. So this one has a quotient rule. This one I'm going to just do quotient rule for. Yes, you could do, not quotient rule, sorry. I'm just going to do chain rule, and you'll see why. I don't know if I said chain rule or quotient rule here, but this is a product rule with a chain rule inside, and this is just quotient rule. Okay, so I'm going to do each of them separately on a separate slide. So 3a, x squared, 7x minus 4. This is f of x equals. Okay, so u is x squared. V, now remember, we never want to see a radical, so you want to see it as a fractional exponent. Okay, that's your first big deal you gotta write. So now we take our derivative of each one separately. So we do little power rules. Now this is where the chain rule happens. So this is going to be 1/2, so the outside function derivative. So you do a power rule on the outside, and then you take the derivative of the inside function. Remember the analogy I gave in the videos. This is like the M&M. You put the M&M in your mouth, you let it melt. The outside shell melts first, then you get to the inside shell, just like that. Okay. So now let's do power rule, product rule. U prime v plus uv prime. So the derivative will be u prime, which is 2x, v, which is 7x minus 4 to the 1/2, plus u, which is x squared, and v prime, I'm going to write this as 7 over 2, 7x minus 4 to the negative 1/2. Now, if you notice, the directions say to leave your answer in non-simplified form, so you can leave your answer just like this. You do not need to simplify it more. Simplifying it more does require a lot more work. I'm not looking for that at this point. I'm looking just to make sure you know how to do your product rule. Okay, question B. Now remember I said I'm going to answer this using the chain rule. Now why is that going to happen? Notice my numerator is a constant function and the derivative of that would be 0. So if you did the quotient rule, u and v, you would get 0 as your u prime and you could go about it as you would and one of your terms would cancel out. So the reason why I'm telling you chain rule works is because it takes out a lot of the steps. What you do is you're going to bring this up and you're going to write this as 3x plus 4. And if you change a position or factor's position in the fraction, its exponent changes, so it becomes a negative 4. Notice I did not do a derivative, I just used my rules of algebra. Now I'm going to do the chain rule. So the chain rule says take the derivative of the outside function, so the derivative of the outside function will be a positive 20, keep that inside function exactly the same, and take away 1 from the exponent. Then you're going to take the derivative of the inside function, and the inside function's derivative is 3. You can leave that as your answer, but just this one's a lot easier to clean up and simplify, so this is what we'd want to see. But you can leave it like this for this exam, and I need to see the work. Okay, so I need to see the work and how you got there. Okay, letter C. Letter C is as clear as a quotient rule as possible, because you have quotient. So u is 3x squared minus 2x plus 1. V is 9x plus 4. U prime is 6x minus 2. V prime is 9. Not V prime. Oh, gosh, I'm so sorry, guys. It is that, but I didn't write. Oh, I did write my u's and v's. Sorry, I had a little brain fart there. So this was my u. This is my v. This is my u prime. This is my v prime. All right, now we're going to substitute this in the quotient rule. So the quotient rule says u prime v minus uv prime all over v squared. So let's substitute those in. Just make sure you put parentheses over anything more than one term. So u prime is 6x minus 2. V is 9x plus 4. Minus u, 3x squared minus 2x plus 1. V prime, which is 9, all over v squared. 9x plus 4 squared. For your test, you can totally leave it like this. You can simplify it. So if you find that you have time and you want a little bit more practice, what you would do is you would FOIL this portion and then you would distribute the negative 9 into that one. So I'll do that for you just so you see it, but for the exam, this is sufficient. So 6 times 9 is 54x squared. 6x times 4 is 24x. Negative 2 times 9x is negative 18x. And negative 2 times 4 is minus 8. I'm going to put the minus 9 through. So it's going to be a minus 27x squared. Negative 9 times negative 2 is a plus 18x. And negative 9 times 1 is negative 9. And keep the denominator in factored form. I need some more space. So I'm just going to make some room up here and bring it up. So let's combine like terms. You have 54 minus 27, so it's going to be a positive 27x squared. You have positive 24 minus 18, so it's going to be positive 6. And then plus 18. So notice the negative 18 and the positive 18 will cancel out, so you're left with a plus 24x. And then we have minus 8 minus 9, so it's minus 17. All over, keep that answer in factored form. Usually in a fun world, you'd be able to factor out that numerator, but that's not factorable. And that's your answer. But for your exam, this is okay. Leave it like that. Okay, question 4, more derivatives, but now we're working on logs and exponents. So let's just recall some of our rules. Derivative of e to the u is e to the u times u prime. If y is equal to ln of u, the derivative is 1 over u times u prime. If y is equal to e to the u, the derivative is e to the u times ln of a times u prime. And if y is equal to log base a of u, the derivative is 1 over u ln a times u prime. So just make note of those so you have those rules, and let's get started. So let's look at rule letter A. F of x is equal to x squared ln of 4x. U is x squared, v is ln of 4x. So u prime is 2x, and v prime is 1 over u times u prime. Now you may be saying, wait, what are you doing here? So I didn't say it at first, but I'm doing product rule because it's x squared times ln 4x. As you heard in the videos, I say to you, if you speak out what you are writing down, it helps you hear what rule you're using. So when I read this, I'm going to say x squared times ln of 4x. And right away I hear the word times, and I think product rule. This simplifies to be 1 over x, and now we're going to use product rule. So u prime v plus uv prime. U prime is 2x. V is ln of 4x, so u prime v plus u v prime. This can be simplified. Given my rules, I told you that you don't have to simplify it, so you do not need to. You can just write that. Also notice, I'm not writing any ddx's anywhere. I know that a number of you like to use a photomath app or one of those apps to kind of show you and guide you along the way. Please do not use it on the exam. They show you ways and techniques of doing the work that is quite different and a lot more difficult than I'm showing you. So just see how I'm doing it. It moves quicker, a lot less to write, and you just spew out your material. So don't overcomplicate it. B. F of x is equal to e to the x minus e to the 2x whole over 1 plus x. This is quotient rule, guys, right? So your u is e to the x minus e to the 2x. Your v is 1 plus x. Your u prime is e to the x minus, and this is e to the u, times u prime. So I'm going to write it like that. And my v prime is 1. Here we go. So we have u prime v minus uv prime all over v squared. So u prime, again, anything that's more than one term, put parentheses around it. So u prime is e to the x minus 2e to the 2x. U prime v minus u v prime all over v squared. And again, this is sufficient for your exam. You don't need to do more than that. If you were doing this to combine like terms, you would FOIL the first two and distribute the negative, but we're not going to do that here. And lastly, letter C is just that last rule, second to last rule that I wrote earlier on. If y is equal to a to the u, the derivative is a to the u, ln a, u prime. So this is it. The derivative is, keep exactly what you see. I was writing a, I'm going to write 3. Then you write ln of the base, and you do the derivative of the exponent. And that's it. And they can't be combined. This is exponential, this is logarithmic. That's just plain old regular polynomial. All right, so question 5 gets everybody every year because they think, oh my gosh, I gotta do the limit, definition, derivative. Absolutely not. This is just a plain old regular, do regular old derivatives, and then find the equation of a tangent line. So remember what your steps are. First, find your derivative. Then find your m. Your m is equal to the derivative at the x value that is given. Thirdly, substitute into the point slope formula the information that you have. So basically, you have a y1 and an x1 given to you, and you have an m that you found in step 2. Sometimes you're not given the m, sometimes you're not given the y, and that you have to just substitute by looking at the original function and substituting it in. All right, let's go. So the derivative is 2x. See, I'm not doing limit, definition, derivative, right? Easy. Don't make your life nuts. So m is equal to f prime, and the x value that it says here, it says the 0.12, right? So you're looking at f of 1. So it's going to be 2 times 1, and that's 2. Then we substitute into the equation. This is your x1, this is your y1. So y minus y1 equals m x minus x1. And you can leave your answer like this, but if you wanted to be able to graph it and check and see, I add 2 to the other side, so y is just equal to 2x. And that's your answer. It does not work out often that the derivative is the same thing as the equation of the line tangent to the original at a point. Just worked out this way. Do not expect that on your exam. All right, let's take a look at this now. So a number of you had asked about this question as well, looking at where the graph, value limits graphically. So remember when I did this in the videos, I said to you, imagine you're a little person walking on the line, and that gives you a really good perspective on if you're approaching from the left or the right. So notice this x approaches -2 from the left side, and you're just looking around the neighborhood of -2. Because oftentimes people are like, oh, but I'm starting here. No, that person's not starting there. You're looking at as you get close to -2. Who cares about what happened further away from it? We're looking as it gets super close to -2 from the left side. So right here, as I get close to -2 from the left side, it's approaching 0. Bam, done. Now let's look at as it approaches -2 from the right side. Well, that brings me to this line. So it's like you're walking on this side and going, whoop, you're getting close to the y value of 1. You're looking around the neighborhood around it. You're zooming in just there. Everything else doesn't mean anything. Let's focus on the number that it gives you. Because then eventually you'll have other questions, right? Like later on, that tell you to look at the others. So like, notice now this question combines A and B because this says no direction on it, right? So if there's no direction, this is similar to the second question that we had. The limit on the left has to equal the limit on the right in order for there to be a limit, but they're not, right? So this answer would be D and E. It does not exist. Notice that the similar thing happens in letters D and E. There is no direction, so that means you have to consider left and right. So as x approaches -3, here's -3, right? From the left side, the function is getting close to 0. From the right side, the function is getting close to 1. So this would be D and E as well. Let's look at +5. Here's +5. Let me use a different color. As I approach +5 from the left side, it's getting close to -1. As I approach +5 from the right side, it's getting close to -1. So this answer is -1. Another way to think about it is, remember we talked about continuity and we talked about discontinuities and jump discontinuities. So if you look at the picture on x approaches -3, this is a jump discontinuity. You jumped up. There's no way there's a common limit there. The limit does not exist. Same thing here at -2. There's a jump discontinuity. But here, this is a continuous function. It may be cornered, but it's still, you don't have to pick up your pen to draw it. I see my graph and I'm losing it here, so let's rewrite it. All right, let's look at now f of -2. These are values, so this is what you would have answered in your pre-calc class, not even in this class. So f of -2, where it's pointed and filled in, so that would be 0. F of -3, where is it filled in? That would be 1. F of 5, where is it filled in? -1. You look at where it's discontinuous, so that's where there are jumps and holes and nothing is filled in. So right here there's a discontinuity, right here there's discontinuity, nowhere else I have to pick up my pen. So it's discontinuous at -3 and at -2.